Hi, I'm Yadin David, the President of Global Clinical Engineering Alliance and the Editor-in-Chief of the Global Clinical Engineering Journal, having immense pleasure to introduce today's expert and coach who is going to address the subject that we're all familiar with, PM, plan maintenance. Matthew Baretich has not only a great education, but his applied field of directing biomedical engineering programs at different healthcare provider is going throughout history of several decades. I have the pleasure not only to know Matt as an expert in the field of clinical engineering and compliance, but also as a good friend and a doer. Everybody rave about his ability to train and coach different professionals in the field. And today, I'm sure you will enjoy his presentation. His education started with undergraduate degree in electrical engineering. He continued to have a master's degree in biomedical engineering, both from the Iowa State University, and then achieved a doctorate degree in hospital and health administration from the University of Iowa. In addition to his education, he's also achieved tremendous recognition through professional registration. He is a registered professional engineer in the state of Colorado, a certified clinical engineer, a certified healthcare facility manager, a certified professional in healthcare risk management, and finally certified professional in patient safety, all supporting the total discipline and plan maintenance topic that he is going to teach us about today. He received several awards, just going to highlight a couple of them. The AMI HTM Leadership Award, the ACC Life Achievement Award, and the ACC he is inducted into the Clinical Engineering Hall of Fame. Maybe most important to me is that he is a member of the editorial board of the Global Clinical Engineering Journal, as well as some other publication in the field. In today's presentation, Matt will cover the objectives of planned maintenance, cover the terminology, what does it mean, what PM stand for, and the objective of such a program. And finally, he will cover the different activities under such program and how do you determine the program performance. He is a principal of Baretich Engineering Consultant, and currently is involved or working or practicing in the Lower Mainland Biomedical Engineering Department in Vancouver, Canada. It is my pleasure to hand the microphone to you, Matt. Please, the floor is yours.
Thanks, Yadin. Good morning, everyone. Greetings from Vancouver Island in Canada. I'm here to talk about PM, or planned maintenance. And it's an important topic because it's something that we spend maybe half of our time doing as we are supporting medical equipment. And so let's just jump right into it. PM, most people would say PM stands for preventive maintenance, and we understand why that's the case. In a little bit, I'm going to suggest that there's maybe a better term. I prefer planned maintenance, but whatever you choose, PM is what we call it, and it really means scheduled maintenance. It's the kind of thing that we do on a scheduled basis. We regularly do something to the equipment to take good care of it. And so I call it planned maintenance, and I'll tell you in a couple of slides why I prefer that term over preventive maintenance. But you can call it what you like, as long as we all get it done. The objectives of a PM program, there are three main ones. And the first is that we want to have safe, effective, and reliable medical equipment. So safe means it does not present an undue hazard to patients or to the users of the equipment. Effective means it does what it was designed to do, whether it's diagnostic or therapeutic or monitoring, whatever the device is intended to do, that it's effective at doing it. And reliability is an additional factor, which is that we want the patient care providers, nurses and doctors and technicians and all the rest, to be able to rely on the equipment, that it will work and be available when they need it. So these are the primary objectives that we have. But also, more in a financial point of view, we need to extend the useful lifetime of the equipment that we take care of. That's expensive to replace, and if we can do good PM, we can keep it working longer and save resources for the healthcare delivery system. And I have at the end some references, one of which it really talks directly to this particular topic. And the third thing that we can't forget is that most of the authorities having jurisdiction, like an accrediting organization or the government or some other entity that we care about, generally has some requirements for doing PM. And so a good PM program is essential for compliance with those. For example, the accrediting organizations have requirements for doing PM on medical equipment. So a little bit about terminology for PM. PM activities. It's what we do. It's the list of things that are on the list of things that need to be done. So, for example, checking the flow rate of an infusion pump and checking the output of a defibrillator. So those are the things that we do. And it's also important to determine when we do it. And that can be, most commonly, that's by the calendar. So we do this PM every year in January, or we do it every 6 months, but somehow we have a way of deciding when we do it. The other common way that PM frequency is established is through meter readings or something like runtime. So, for example, after a certain number of hours of operation, we would do PM on a ventilator. And if you put all that together, you create a PM procedure. It's a set of PM activities and the specification of when it happens. So defining what the PM procedure is that's appropriate for each device that we take care of is an important part of designing your PM program. So this is an important slide that I want to take a little bit of time with. There are different aspects of PM activities that I think it's useful to think through as we're planning what work we do. So there's one aspect, which is device restoration, is one way to call it. This is genuine preventive maintenance. And it's things that we do to reduce the likelihood of failure. So it's lubricating, and it's changing filters, and it's changing batteries and other things that restore the device to its original capability, and it prevents future failures. So, for example, if we replace the battery on a regular schedule that is appropriate to the kind of device and the kind of battery, we make it less likely that the battery is going to fail when it's being used by a patient, by a user for a patient. So we're preventing problems by doing that advanced aspect of PM called device restoration. It turns out that actually most of the things that we do in PM are more safety and performance verification. It's not exactly preventive. We don't have many things that we need to lubricate, for example, because we deal with electronic devices more than we do with mechanical devices. So a lot of what we do is inspecting for safe and effective function. So we measure electrical safety to make sure the device is safe. We measure the flow rate of the infusion pump to make sure that it's functioning well. And what we do when we do that is we identify latent or hidden failures that are not obvious to the user. So the user is not going to know that the electrosurgical unit output is a little bit low. They normally just, if it's not accomplishing the surgeon's objectives, just turn up the dial a little bit. But there could be an underlying or hidden failure that that is important to find out and take care of so that it doesn't cause a problem later. And typically, this safety verification, if it's not something the user can do, it's something that requires the specialized knowledge of our technicians, our technologists, or excuse me, requires special test equipment. So these are the two aspects of PM that I think it's important to keep in mind as we design our PM programs. So when we put together a PM program, we need to monitor the performance of that program. So for example, we want to make sure that the PM program we have put together is done correctly and that it's working. In other words, we are improving the safety and reliability of the equipment, that we are actually preventing some failures. And so performance monitoring becomes really important. And I do, again, at the end of the presentation here, have some particular references for how you do it. But let me give you some overviews. So one of the most straightforward and simplest kinds of monitoring techniques is your PM completion rate. And so what you're looking at is if you schedule a certain number of devices over some period of time, then you look at how many of them actually got completed on schedule. And that gives you an overview of how well you're adhering to the schedule that you've put together. Now, the one other factor that's on this screen is minus the number of devices that are unavailable. So for example, if a device is, it simply cannot locate it after working hard to find it, obviously you can't do the PM on it. If the device is in use with a patient, again, we cannot interfere with the patient care and do the PM. So you can also, in doing your metrics, take into account the fact that sometimes PM is unavailable. But all of that's discussed in one of the references that I'll show you later about how you can work with the various versions of this performance metric to make sure that that you're getting the work done in an appropriate schedule. Another sort of metric that's important is one called mean time between failures, or MTBF. And that's a measure of reliability. And so the equation here does a calculation based on the number of devices you're looking at and the period of time over which you are reviewing the performance of the program. But the denominator is the important thing. In the denominator, you put the number of failures of all kinds, failures that occurred over that period of time, and calculate a number here that so you want the mean time between failures to be long, the average time between failures to be long. But if the MTBF starts to get low, that's an example of evidence that there is the equipment has become less reliable and has started to fail more commonly. So to make this statistic work, it's important to be tracking the failures, all kinds of failures that occur with your devices over a period of time. So that's all of these metrics depend on collecting good and accurate data, complete, accurate data of what's happening with your program. And that allows you to calculate these metrics. And of course, the reason for the metrics is if you see some fall off, some deterioration in your metrics, then it means I need to dig into my PM program and find out what the problem is and make some effort to correct that. So what I want to talk about is a thing that is PM related failures. So let me give you an example. Let's suppose a patient care provider is attempting to use an infusion pump to achieve some objective, to treat the patient, and that provider is unable to get it to work. So that's a failure that's a failure in the ability of the medical device to support patient care. Now, if the failure is because the user has set up the pump improperly and, for example, has made an error in programming, that's a genuine failure, and it's important that we keep track of that, but it's not related to PM. And what I mean by that is that just doing more PM is not going to address that problem. It's important to track that failure and to recognize that perhaps there's a need for some training or other sort of support for the user, but it's not directly related to how you design your PM program. And here are a couple of ways that things are related to the PM program itself. So anytime we would find a failure that could have been prevented by better PM, that would be a PM-related failure. So an example would be if, back to that infusion pump battery, if there's an early failure in an infusion pump battery, if that's the failure that occurs, it comes to our shop with the battery having failed. We need to do a repair or corrective maintenance. Maybe that could have been prevented by better PM, meaning change the battery more often or buy a better quality of replacement battery or something like that. So one aspect of PM related failures are failures that could have been prevented by changes in our PM program. The other aspect of PM related failures is that it could be hidden failures that could have been discovered by better PM. So for example, a low defibrillator output, we discover that because we come around with our defibrillator tester and we measure the output and compare it to the expected values. And so if it comes out short, that's hidden typically from the user. And it could only be discovered by us coming around and doing that actual inspection. So that would be a PM-related failure in the sense that if we start discovering that there's low output from our defibrillators, then what do we need to do about that? Maybe we need to test that more often. Maybe we need to, it depends. Here's the reason that we do these metrics is it alerts us to a problem in our PM program, and then and then gives us the information to start digging in and figuring out what the underlying problem is, what the root cause is. So all of this, of course, is directed toward learning what we need to do to take better care of the equipment. So the only change that happens with MTBF, and I don't know if this is being blocked behind the screen, the picture of my face up here in the screen, but it's MTBF for PM, and it's the number of devices. It's the same equation. It's just that the denominator is limited to only PM related failures. So preventable failures and discoverable failures. So it's a slight modification of the equation that can be applied. And I'll say it one more time. I'm going to now start giving you some references where if you want to dig into some of these things more often, more deeply, you've got the references to do it. So here's some references. Both of these are references to ongoing maintenance programs. And one of them is the NFPA 99 Healthcare Facilities Code. And any of the versions from 2012 or later are similar, are identical in terms of PM requirements and similar in other areas. The other thing you can do is the other reference that you might consider is this IEC reference. And I will tell you that I prefer the NFPA document because I think it's more practical. On the other hand, if you're in a country or a location that has adopted IEC 62353, then you may wish to do that. Neither Canada nor the United States have adopted that, but it is used elsewhere, particularly, I believe, in Europe. Some other references. There is a free from Amy white paper called Planned Maintenance Compliance Definitions Guide, and it goes over the details of some of those metrics. And so if you're working on your PM program, get a copy of that, and it's a good short reference. There's also another white paper also available free about how to use failure codes in your CMMS. And one way to use it is in calculating MTBF for PM-related failures. So you can again get that at short and free from Amy. And this is an article that I wanted to draw your attention to. Binseng Wang and his colleagues recently wrote a series of articles, a three-part series in the Journal of Clinical Engineering on medical equipment aging. And part 3 particularly shows evidence from lots and lots and lots of data, maintenance data, about how good PM can extend the lifetime of equipment, and that, as we all know, all of us in every part of the world are keeping our equipment much longer and longer. And so the more we can do to keep the equipment safe and effective and reliable over its entire lifetime, the better. And one more page of references. There is an AEM program guide that's available from Amy. It talks about some of these, some of the things I've talked about today, but also goes into some details about how you can consider, with good data, deviating from the manufacturer's recommendations for PM. It's an option to save yourself some PM time without adversely affecting safety and effectiveness and reliability, but it takes some overhead work. And this is a good disciplined process for doing that. And So you can see my name there. I wrote the guide. I didn't write the idea of AEM programs. That's from the U.S. Centers for Medicare and Medicaid Services and from the various accrediting organizations in the U.S., but it's applicable in many different environments. And there's also one other reference that you might consider getting. There's a reference on setting up CMMS systems to support among other things, different kinds of setting up your PM program. So here's my contact information. Don't hesitate to contact me if you want some additional information or if you have some questions for clarifying this material. I would be glad to talk to anybody who's working in this area. And with that, I will stop and say thank you very much for your kind attention.